Hello everyone. In this video, I'm going to set up a very simple RAG pipeline using LlamaIndex, and I'm going to show you how to easily add some tracing to the components of it using a project called OpenLLMetry. As much as building AI applications, observability is my passion, so having clear insights into how your app or pipeline works is at least helpful, at most essential. So let's start. We'll start building our project from scratch. I've created a directory called Simple RAG with OpenLLMetry, and I'm going to share it on Github. You will find the link. So let's start initializing the project. I'm using UV to build it. So UV init, and we initialize the project. So as I said, we're going to build a RAG pipeline using LlamaIndex. So that's the first thing that we're going to add. UV add LlamaIndex as a dependency here, right? And we'll also use some defaults like the embedding models by OpenAI and also the OpenAI API for the LLM used in the RAG pipeline. So we just as well add the OpenAI as dependency here. So let's go and see what's in the main code. You see it's pretty bare bones. So I'm going to copy some of the code that I have already done, and I will explain how that works. So here we go. We're gonna run a quick RAG pipeline, right? I've created a bunch of documents just in memory. We create some documents with text, pretending that I'm having lots of animals around my house and in the backyard, right? And so we're initializing a vector store index, which is in memory one, and then we use it as a query engine so that we query, hey, how many dogs does Anton have? And it should find the answer from these 4 documents here. So let's just save it and let's start running. And I'm gonna type in the terminal uv run main.py. It will take a while, so let's see how that goes. All right. You see the response. It was able to figure out of this pretty unusual sentence, right, for it that I actually have 2 dogs. Well, I don't, but let's pretend I do. Now, let's make it slightly more complex. I would want to add some real components. For example, I'm going to add ChromaDB as the vector store here. We replace the in-memory vector store with the more production-like scenario of the ChromaDB. I'm going to use Docker Compose to run some of the components. Feel free to use anything else. So I'm going to create a new file, docker compose.yaml, and I'm just going to put there some service called Chroma, right? So it will download the ChromaDB container image, run it as a Chroma container, right? And store some data in the Chroma-data. And I'm gonna expose it under port 8001 so that it is available. Let's just go and see whether it's running well or not. I'm gonna make it a bit larger so that you can see. Let's run Docker Compose up. All right, as you can see, Chroma did started successfully, and it's listening on port 8000, though it is exposed as port 8001 to the application that we might want to use. So let's start using it, right? Let's go back into our code, into the main.py. So let's replace this index, right, with the actual ChromaDB index, right? So again, I had some preparation, so I'm copying, pasting, and I'm going to explain what it is and how that works. So basically, that's the remote database, the Chroma database under the port 8001, right? I'm creating a collection, just arbitrarily named my documents, right? We create the LlamaIndex based Chroma vector store, right? And now use that to create vector store index, and all the rest stays the same, right? So now in order to run that, we need to also install the LlamaIndex Chroma vector store. So let's do that. UV add LlamaIndex vector store, Chroma, and add the actual ChromaDB as a dependency here. All right. Let's structure the code nicely so that we have indexing and querying separately. And this will look like that. So we keep the same documents, we index documents, and then we query documents. So I will replace this one and only keep the code initializing the index, and the rest will just stay as is. And we'll pull the index initialization right here. So let's save it. Let's now run it. So now that pipeline should connect to the ChromaDB, right? Index the documents, these documents that I provided, right? Just some text. And then the query this document. So basically from the interface perspective, nothing has changed, right? We do the indexing and querying, but then now we do that with the ChromaDB as a vector store at the backend. And you see it works the same. It still responds with the same answer, right? All right. Now let's finally, we now have the RAG pipeline, right, working. Let's finally set up the OpenLLMetry for it, right? And I would want it to be sending the telemetry and traces into the Datadog as the OTel backend so that I can visualize it and see, right? So make sure, if you're following it, make sure to set up your Datadog account, get the API key. I have it already there, so I will be setting it via the envvars everywhere. But I'm gonna run, first and foremost, I'm gonna run the Datadog agent within the same Docker Compose file that I have. So let's go back, stop the Chroma, and I'm gonna add another service here called Datadog, right? So when I run it, I'm setting up the Datadog API key, right? It's already in my envvars, so you will not see it. But one other thing we need to do is we need to have the Datadog agent act as a OTLP OTel receiver through the OTLP protocol. So let's add it here, some configuration that, hey, the Datadog agent needs to receive OTLP at the HTTP endpoint 4318, right? And also with that, we need to open the ports, right? So that they are available. We do that, and so it should be available. So let's run now and see, again, Docker Compose up. So now we're running both Chroma, you see it started, as well as the Datadog agent. All right. Let's wait until it starts, and then we should be good to proceed with the rest of our code. All right, looks like it's running checks. It's responding well. It says done running checks, so not complaining, so it should be available. Let's go back to our code. Now what we do to have the OpenLLMetry set up is a very simple thing, right? Basically, we just add a couple lines, and it works just as OpenTelemetry out instrumentation. So the folks from TraceLoop, which is why you will see here TraceLoop SDK, right? They have done it so that it goes and out instruments. They have lots of support for different libraries, LlamaIndex including. So they just go and instrument everything so that you see the components reporting the traces. Basically, that's most of what you have to do here, right? To have this work, we also need to add the TraceLoop-SDK as a dependency. That's what I'm doing. This one is done. So one other thing is it needs to know, like, what is the OTel backend, right? What is the OTel collector that should be receiving the metrics, right? It is, for that you need to set the environment variable called traceloop base URL, and I'm gonna set it like that, so it's gonna be http / localhost 4318, just as we have set it up before, right? The Datadog agent at port 4318, and this way the traceloop SDK will know where to forward the telemetry. All right, now let's run and see how that works. So I'm gonna run uv run main.py again. All right, it has completed. It produced the answer. Now that's not what we're looking for. We're looking for telemetry. We're looking to find the traces. So where have they gone? I'm opening my Datadog dashboard here, right? So let's go and see in the traces explorer, right? I have plenty, so let's figure it out by the time. So just recently we received a number of spans and traces, right? You see here now we have these spans here, right? And so here's an example, right? This is the querying engine, right? So it labels some of the steps here, so you can see first and foremost, like this is for the query part, right? So it goes and uses the OpenAI embedding to embed the query. If we click here and scroll it down, right? So it calls OpenAI embedding API, right? And gets the embeddings for the query that I have, how many dogs Anton has. And here's the other part of it, right? The synthesizer, right? Basically querying the LLM now with the context that we have retrieved and with the query, right? So if we scroll it down into the chat, right, you see lots of defaults that I've used, right? So the content says you're an expert, blah, 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 right? And so the LlamaIndex produced me some content, right? So it included the context, which was retrieved, the most applicable context, right? And also the query. And so if we scroll it up, the completion, you see that's the response from OpenAI API saying that Anton has 2 dogs here, right? So this looks nice, right? But I would want even more structure than that. So let's go back into the code and edit a bit. So one of the nice features of traceloop here is that we could add some decorators that would say, this is a workflow, this is a tab, this is a task, right? So let's add a few. So I'm gonna copy these imports for the decorators, right? So workflow and task. So we'll say, this is my general workflow. Run quick rag, right? And I'll call it quick rag. And then we'll have tasks, right? So this task is index documents. The other task, query documents, right? So now let's see what happens when I run it once again. So we'll have the full observability into how everything works in the pipeline, both the indexing side and the querying side. All right, it has completed. Let's go here. Let's refresh it here. Again, something more or less recent, these ones. All right, you see now we have this workflow that I named quick rag, right? I'm gonna open it full page. All right. Yeah, so that's the whole workflow. Out of these workflows, we have 2 tasks, the indexing and the query, right? That helps you getting a sense of how the RAG pipeline works, right? So you will see that actually, hey, we're, here's node parser workflow, right? Another one, and there's another one, and there's another one, right? So basically it indexed the 4 documents, right? It didn't batch it, it just indexed the 4 documents. So for each, it received the embedding. Let's go and check what it did. So yeah, it went to OpenAI API. Oh yeah, in the traceloop entity. Yeah, so that's one of the documents, right? This is the first document. So just take that document, basically that text, it didn't do any chunking, and produce the embedding for it, right? And then the next step for this document is index it into the vector store, into Chroma, right? It says Chroma. So that's the indexing, right? You don't see anything else here. And again, going back to query, so it goes into the query using the query engine, right? It goes and retrieves the most relevant vectors from the vector store, right? First of all, of course, it gets the embedding for the query, right? And then goes and queries Chroma, and it probably returns a few results here. And then it just packages it, everything into the OpenAI chat API, right? Sending it like, hey, this is the content. You have the context, the most relevant document, and then the query. And then it returns the most appropriate answer here. That's the response of the model. All right, basically that's it. I hope you enjoyed it. Yeah, and I will be rolling out some new stuff soon. Thank you.